Hey everyone, I'm Babu Khandelwal and I welcome you all to Simplilearn's YouTube channel. In this session, we will discuss fractional or 0-1 knapsack problem. We shall begin our session by discussing what is knapsack problem. Then, we will go into the details and discuss the 0-1 knapsack problem. After that, we will look into its implementation in the code editor. Then, we will discuss the fractional knapsack problem. Finally, we will dive into its implementation in the code editor. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon below so you never miss an update from Simplilearn's YouTube channel. So without any further ado, let's get started with the topic, what is knapsack problem? The knapsack problem is used to explain both the problem and the solution. It derives its name from the fact that the limited number of things that may be carried in a fixed size knapsack. Given a set of items with varying weights and values, the goal is to pack as much as value as possible into the knapsack while staying within the weight limit. Now, let's discuss 0-1 knapsack problem. First, we will be given weights and values of n items. In this case, 6 items on the left. We will put these items in a knapsack of capacity W, or in this case 10 kgs, to get the maximum total value in the knapsack. Then we will have to fill this knapsack, but we can't break the item, so we must either pick the entire item or not pick at all. Due to this, sometimes it may even lead to a knapsack with some spare space left with it. Now, let's try to implement this in the code editor. We will start with the utility function that will return the maximum of two integers. So int max a comma int b. We will return if a is greater than b, then a else b. We will now write a function to return the maximum value that can be put in a knapsack of capacity W. Int knapsack int capital W, comma int wt for the weight, comma int value, comma int n. We will declare int I, comma w. We will create a vector. Inside a vector, k n plus 1, comma vector int capital W plus 1. Now we will build a table K in bottom up manner. So for I equals to 0, I less than equals to n, I plus plus, we will have another for loop inside it. For loop with small w equals to 0, this small w will be less than equals to capital W with small w plus plus. Now if I is equals to 0 or w is equals to 0, then we will have k at I comma w is equals to 0. Else if weight at I minus 1 is less than equals to weight w, then k at I comma w will be equals to max of value at I minus 1 plus k at I minus 1 comma w minus wt, where wt is at I minus 1 comma k at I minus 1 comma w. Else we will have k at I comma w is equals to k at I minus 1 comma w. Now we will return k at n comma w. Now we will write the main block. We will start with int value array, which will have elements as 60, 100, 120, and weight will be equals to 10, 20, 30, and the maximum capacity, the capital W, will be equals to 50. Now let's find the size of the value array. So int n is equals to size of val divided by size of val at 0th location. Now we will print cout knapsack at capital W, comma WT, comma val, comma n, and return it as 0. Let's compile it. As you can see, we are getting the value as 220, which means we are getting it because we are taking the elements with weight equals to 20 and 30, which comes out to be as 50. Let's get back to our slides.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill Up by Simplilearn. Click on the link in the description to know more.
We have now discussed 0-1 knapsack problem. Now, let's discuss the fractional knapsack problem. Similar to the 0-1 knapsack problem, we will be given the weights and the value of n items. In this case, 6 items on the left. We will also be getting a knapsack with capacity W, or in our case 10 kgs, to the right. Now we have to get the maximum total value in the knapsack. Then we will have to keep filling this knapsack, but unlike 0-1 knapsack, we can break an item to get a maximum value of knapsack. Here we will break this 3 kg item into a 2 kg and 1 kg item to fill the knapsack. Now let's try to implement this in the code editor. We will start with the structure for an item which stores weight and corresponding value of item. So struct item int value, comma weight. We will write the constructor as item with the argument as int var, comma int wt weight, where this value will be equals to val and this weight will be equals to weight. Now we will write a comparison function to sort items according to value by weight ratio. So Boolean function CMP with argument as struct item A, comma struct item B. Now double R1 is equals to double A dot value divided by double A dot weight. Similarly, we will write it double R2, which will be equals to double B dot value divided by double B dot weight. Now we will return R1 greater than R2, which means it will return true if R1 is greater than R2. Now we will write the main function to solve the problem. So double f knapsack with argument as int capital W, comma struct item arr, comma int n. We will first sort the item on the basis of ratio. So sort arr, comma arr plus n, comma cmp. Now int current weight is equals to 0 and double final value is equals to 0.0. This will be result value in knapsack. So for int I is equals to 0, where I is less than n and I plus plus, now if adding the item won't overflow, then we will add it completely. So if current weight plus AR, ARR at I dot weight is less than equals to capital W, then current weight plus equals to ARR dot weight and final value will be plus equals to ARR at I dot value. Now if we can't add a current item, then we will add fractional part of it. So else int remain is equals to w minus current weight, then final value will be plus equals to ARR at I dot val multiplied by double remain divided by double ARR dot weight. Now we will break, then we will return final value. Now let's write our main block. We will start with defining int w equals to 50. This will be the weight of the knapsack, and item ARR equals to element as 60, 10, 100, 20, 120, 30. We will find the size of n int n equals to size of ARR divided by size of ARR at 0th location. Now we'll make the function call. So cout maximum value can obtain equals to f knapsack w ARR n. Let's execute this. As you can see, we are getting the maximum value as 240. That means our function is working flawlessly. Let's get back to our slides. And this was all for today's session. Hope you guys found it informative and helpful. If you liked this session, then like, share and subscribe. If you have any question, then you can drop them in the comment section below. Thanks for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.